Okay, so fireworks. Now they're really cool. They explode in all sorts of colorful little sparkles and such. But what's even more cool is all that is done with science. It's all done with something called photoelectron spectroscopy. Here, I'm going to write that out now. Photoelectron spectroscopy. Photoelectron spectroscopy. Now that's a really big word. We're not going to get it really into, that's not really important. We're just going to think, okay, it's what makes little colorful fiery boobs, right? Now all that, what does that have to do with fireworks? See, first, I'm going to erase this real quick. Fireworks, what's in a firework? Fireworks, I'm going to draw one right here. They are made, of course, with a little explosion inside, a little fiery boom. I'm gonna draw a little red little core inside. That's what creates the explosion. But something else too. And that's, I don't know, any sort of different material. Something like, I don't know, sodium, or copper, or iron. And all of these, by adding this little element in here, it changes the color of the fires when it explodes. But why does that happen? And for that, we're going to know what is this little element made of? He's made up of atoms. Little atoms over here. Atoms. And these atoms, they are made of a bunch of different little stuff. Here, I'm going to show you. This little atom here, you can visualize him as like a little marble. Big old sphere. And inside him is a little nucleus. I'm going to draw a little nucleus in the center here, and he just chills in the center. And that nucleus is made up of a proton. Proton. I'm going to draw a little dot here. He's made up of a proton. That proton is positive. I'm going to draw a little plus sign there. He's a positive charge. And that doesn't mean much. That positive charge doesn't mean much to us until we add the electron. I'm going to draw another little circle here. Electron. Okay? And what's special about him is not only does he also live in the atom, he doesn't live in the nucleus, though. He lives in this sort of space around the atom. And he has a negative charge. So, what do these positive and negative charges have to do with each other? Well, you can think about it kind of like magnets. You know, I have a couple magnets here already. A little magnet here and a little magnet here. And on one magnet, you have a north side or a positive side, and one a south or a negative side. And if you stick those sides together, they want to stick together. But if you put the like charges together, if you put a negative and a negative side together, they don't want to go together, right? And it's the same thing with these protons and electrons. One has a positive charge and one has a negative. These positive and negative charges, they like to go next to each other. They like to stick together. They're attracted to each other, you could say. But an electron, they don't like each other. They want to stay as far away from each other as possible. And that leads to this sort of formation in the atom. See, what happens is these protons, they're in the nucleus, right? And they just stay there. They don't really move much. But the electrons, they're out here, and they want to get close to this proton in the center. But at the same time, there's other electrons outside in the atom as well, and they want to get in close. But the closer you get, the closer they also get to each other. So they end up making these little rings around the nucleus. And we call those electron shells, or energy levels, you could also say. And in the first one here, you can only fit two. You can only fit so many in an electron shell, and the first one you can only fit two. But what happens when you add another? He ends up going into the second energy level. And what's special about this is Here, I'm going to erase this. Okay. What's special about this is, since remember, I'm going to draw this in a little way that's going to be easier to visualize. So I'm going to draw one line here and one line here. And the nucleus is going to be down here. So I've just flattened these energy levels out. Nucleus is down here. All the electrons want to go down. And so one is going to be, one or two, let's put two down here, are going to want to be in here. And that's how many can fit. There's no more space. They just repel each other too much. And all of the others stay up here. But what happens, say, when you add some energy to this atom? What happens is these electrons absorb that energy, and they get all excited. They get all moving around. They want to move around a bit, but there's no space. There's too much space in this energy, and there's too much electrons. Not enough space for this energy to move around as he wants. So what he does is he goes up to the next energy level where there's some more space, and he flies around in there. But remember, he really, really wants to go down to that proton, get as close as possible. And he's going to try and get down there. But remember, that energy is keeping him up there in that second electron, in that second energy shell. So what he does is he needs to get rid of that energy in order to go down to the closer shell. And one way that he does get rid of that, the only way, is he releases a little photon. It's called a photon. I'm going to do a little orange for him. And what a photon is a little light particle. So what this means is we can know that if we add energy to this atom, it'll release some light. And that is very interesting for us, okay? And once again, he releases that energy, he goes back down, and he lives in his little happy place, really close to the nucleus, to the protons. So I'm going to erase this now and show you back on our original atom diagram. So we have our little diagram with the nucleus in the center and the little rings with the electrons in them. And when you add some energy, one will pop up to the next level, but then to get rid of that energy, he'll pop back down, he will release a photon, some light. But at the same time, not all of these atoms are the same. They won't release the light in the same manner because all these elements, all these atoms for different compounds like iron and copper and sodium, they're all different. Like for iron, it doesn't have 2 or 3 electrons. It has 26. For sodium, it has 11. Helium, it has 2. And this causes this different structure causes the light to release in a different way, and we call that frequency, right? It can be represented by a little wavy line. And that frequency, changes in that frequency in a light particle or a photon, will cause that photon to emit a different color of light. Say for sodium, it might emit purple light, or actually, if I remember correctly, it's an orange light. And another element could emit a blue light. So that's really interesting. But, I mean, I keep talking about this energy that. How do we get this energy? Well, one really main way that we get energy is fire. Fire, big explosions, heat, energy. Okay? And where can we find that energy? In these little firework rockets. So what people do is they have in these little firework rockets, remember, they would have their little explosive. I'll put the little orange core in there. And they have a different element or a different material in there. Put some little green stuff in there. And when this explodes, it adds energy to that little compound, that little element. and it'll cause those atoms to excite, go to the next energy level, and then come back down and emit those different colored lights, depending on which element they have in here. And that's how fireworks work.